Hello everyone and welcome to our live coverage of United Launch Alliance's launch for USSF-106 mission, marking the first US national security launch aboard a Vulcan rocket. Hope you all are doing fine and excited about the upcoming first national security space launch mission on a Vulcan rocket. If this is your first time here, hi, my name is Dipto Moitra. I'll be your friend and the host providing commentary for today's mission launch, and you are watching AstroYonder live.
Roger, 0G, and I feel fine. Capsule is turning around.
Houston, we see a nominal MECO. Welcome to space.
Really excited to bring you the live coverage of United Launch Alliance's launch for USSF 106 mission, the first operational US national security launch aboard a Vulcan rocket, marking United Launch Alliance's 162nd overall launch and the third flight for Vulcan. Now, before we ignite our thrusters on today's mission details, a big thanks to you all from all of us here at AstroYonder team, along with our incredible moderators for joining us on this launch ride. We are truly fueled up by your presence and support that inspires us to work more hard and to meet your expectations. A big thanks to our amazing YouTube community for the encouragement that keeps our mission flying. A heartfelt gratitude for supporting us to bring you deep dive launch coverages loaded with all the stats and insights. We are grateful to have you on board as we count down to the liftoff together. ULA will be beginning their webcast 20 minutes prior to the liftoff. We started a bit earlier so that we can share all the insights and stats regarding today's mission launch. Would really appreciate it if you guys could join the chat and let us know where you are joining from. Feel free to share any questions, suggestions, or opinion with us that will help us to improve our stream as well as to know you and your perspective. So please don't be shy, just bring them on. We would love to hear from you guys as we move ahead with the stream. We are waiting for a United Launch Alliance Vulcan rocket launch in its VC4S configuration for the US Space Forces Space System Command from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida within a 1-hour launch window between 7:59 p.m. to 8:59 p.m. Eastern Daytime on August 12th. But currently we are targeting at the end of the launch window, that is at 8:56 p.m. Eastern Daytime, 0056 hours UTC. That's just we are having 3 minutes left before today's launch window expires. Now, just a heads up, I will be providing real-time in-flight updates post-launch, so request you to listen closely. And also, as I am managing the launch coverages on my own, so if by chance we face any technical hiccups or issues, please bear with me and be tuned in. Will do my best to guide you through the upcoming Vulcan rocket launch happening in approximately 63 minutes from now. Now, before moving on, would like to welcome one of our moderator joining us, Angry Bird. It's late at your place, Angry Bird, but still thanks for tuning in. Also, would like to welcome Nick X Model for tuning in. I hope you are still there with us, Nick. Now, as always, here at AstroYonder, we are committed to provide you the best possible viewing experience. So there is absolutely nothing to worry and you won't miss out anything. Now, moving on to today's mission, USSF-106 mission is the first national security launch aboard the certified Vulcan rocket. On this mission, the Vulcan rocket will deploy two US national security satellite missions directly into geosynchronous orbit using the high performance Centaur 5 upper stage. Today, United Launch Alliance will launch the Vulcan Centaur in its most powerful configuration yet, the VC4S variant of the Vulcan rocket. We will break down into the rocket configuration for you and learn more about the rocket shortly. Now, worth mentioning, it will be one of the longest launches ever for ULA, a marathon extending more than uh, 35,000 kilometers above Earth and lasting over 7 hours to complete this mission. Just to remind you, the previous two launches, which were both certification flight for Vulcan rocket, flew on VC2S configuration with two solid rocket boosters. So today's launch is the most powerful configuration of Vulcan as of now, with four solid rocket boosters waiting for its flight. Now let me mention about the weather. According to the 45th Weather Squadron officials and their recent launch forecast report, which got published yesterday, today's weather for the launch looks quite promising with 20% probability of launch weather constraint violations, specifically the cumulus cloud being the major concern as of now. But earlier report of August 10 forecasted a 25% probability of launch weather constraint violations. So that's a quite a nice thing. Weather conditions are rather being cooperative in nature with decrease in probability of violations. Otherwise, today it's a 80% favorable weather conditions for the launch anticipated by the 45th Weather Squadron. The forecast calls for a temperature of 32 degrees Celsius, clear skies with 0% cloud cover and a wind speed of 10 miles per hour. Worth mentioning, if for some reason the launch moves to the backup opportunity tomorrow on Wednesday, there is again a 80% chance of meeting the weather rules with similar conditions. Now, just a quick update. Previously, during the pre-launch timeline, ULA extended the first of two built-in holds to work through the pre-fueling activities to prepare the rocket and pad for propellant load. At that point, the L- clock surpassed the T- clock, which means that they are going to push into the window, which is 1 hour long, and we rather saw that recently United Launch Alliance's launch director directed the team to retarget a new launch time at 8:56 p.m. Eastern Daytime, 0056 hours UTC, which is just 3 minutes before the end of today's 1 hour of launch window at 8:59 p.m. Eastern Daytime. Now, since this is a national security mission, there won't be any payload or second stage views, and the stream will be wrapping up after booster and Centaur separation or somewhat around that point. Now, those who are new to Vulcan rocket, let's meet the mighty Vulcan. At the very base of the rocket, we have Vulcan boosters, which is powered by dual B4 engine For additional thrust required during the liftoff, we have solid rocket boosters. In today's rocket configuration, we have 4 of them. On the top of booster, we have the interstage adapter. Above that, we have the Centaur upper stage, which is powered by 2 RL-10C engine, producing 23,825 pounds of thrust. And finally, at the top of everything, we have our payloads for today's uh, mission, which is protected by a 15.5 meters tall and 5.4 meter diameter standard payload fairing. The fairing comes in 3 variations: standard, long, and multi-manifest long. We will discuss all of them in a little more details to have better understanding. Now let's rewind and see how the mission geared up. It is a quick time-lapse video of the United Launch Alliance's Atlas V rocket from its manufacturing facilities to the pad. Now you can see the Vulcan getting transported from Alabama to Cape Canaveral using United Launch Alliance's cargo ship, also known as rocket ship. After it arrives in Florida, United Launch operation teams begin assembling the rocket. The stacking began back in July 2025 with lifting the 109-feet Vulcan booster powered by twin BE4 engines onto the Vulcan launch platform. And you just saw now the solid rocket boosters also getting attached. Currently, the interstage got hoisted up, and right now the Centaur upper stage, powered by 2 RL-10C engine, and finally the payload fairing containing the spacecraft is lifted and mated to the Vulcan rocket back on July 24, 2025. United Launch Alliance has a proud legacy of successfully placing 100 national security missions into space using their Atlas and Delta rocket families, launching reconnaissance, communication, navigation, missile warning, and other assets into a wide range of orbits. They have also delivered 99 national security missions to orbit successfully since the company was created back in 2006. And also this track record represents 62% of their flight history using Atlas V, Delta II, and Delta IV rocket. Also in future, United Launch Alliance's Vulcan rocket, it can target cislunar orbit and even far energy needed trajectory orbits. Also, it can opt for that. Hopefully, we will be seeing those launches in upcoming United Launch Alliance's missions. Now, if this stream fuels your love for space, please give this stream a like. It's kind of fine-tuning the trajectory of our mission to build a community with amazing space enthusiasts like you. And please don't forget to subscribe and turn on the bell notification so that you won't miss a single launch update. I know it's early in the stream, but so that this stream can reach out to more people, it's just a humble request to you all. Here at AstroYonder, we believe together we will build the ultimate constellation of space enthusiasts. We'd be super grateful for your kind support. Now, moving on, let's learn a little bit about the naming convention of the Vulcan rocket. The Vulcan rocket uses a 4-character naming convention to designate its variants, reflecting its modular design for various mission requirements. On your screen, you can see this naming convention is having a meaning as well, just like Delta 4 rockets. The first character V stands for Vulcan, of course. Second character C indicates the centaur upper stage. The third character specifies the number of solid rocket boosters. For today, it's 4 of them. This configuration can vary depending on customer's need, varying from 0 to 4 and 6 solid rocket boosters. As mentioned before, two flights, the previous two flights were with two SRBs. So in that case, the naming convention was VC4S. And finally, we have the fourth character. Here on your screen, it's written as S, which denotes the fairing size, which is the standard variant for today. The payload fairing with common 5.4 meters diameter are available in two lengths, standard or long, where the S stands for standard and L stands for long. And the standard variation of the payload fairing measures 15.5 meter, that is 51 feet in length, and long measures 21.3 meter, that is 70 feet in length respectively. The most powerful configuration of Vulcan would be VC6L. Previously, Vulcan's first flight with Peregrine lunar lander under NASA's CLIPS program, and the second one, the certification flight 2 with inert payload. Both of them flew on VC2S configuration. But the upcoming planned Dream Chaser will fly on a VC4L. So in that case, it will be using 4 solid rocket boosters with the long variation of the payload fairing. Now let's dive into the Vulcan rocket and learn a little more in details, breaking down its setup in a way that's easy to follow. Coming from the top, we have the payload fairing. The spacecraft is enclosed in a 5.4 meter, that is 17.7 feet diameter payload fairing, which is a composite structure made from a vented aluminum honeycomb core and graphite epoxy face sheets. This bisector two-piece payload fairing surrounds the spacecraft entirely during its ascent, protecting it from the maximum dynamic stress on the vehicle as well. The payload attach fitting, also known as PAF, which is made from a similar composite material, connects the spacecraft to the second stage and payload fairing. The payload fairing separates using a debris-free system for both horizontal and vertical separation, featuring spring packs and a fragile joint assembly. The payload fairing comes in two configurations, as I mentioned just before a couple of seconds now. The standard version and a long version. With multi-manifest, 2 or more spacecraft are integrated on a launch vehicle using available performance and volume margin that would otherwise go unused, optimizing mass to orbit and enabling the mission need. Although in this multi-manifest variation of the payload fairing, it comprises of the long version of the payload fairing, that is with the 70 feet, which measures in 70 feet in length. It's not, they are just making them like one above another payload so that they can accommodate the payload within the fairing house. On this particular mission, Beyond Gravity built and supplied the payload fairings, the interstage adapter, the heat shield, and the payload attachment fitting. Now moving on, we have the Vulcan Centaur upper stage. The Vulcan Centaur's upper stage, also known as the Vulcan second stage, is powered by two RL-10C engines known for their reliability with nearly 400 successful flights and close to 700 in-space firings. Today's launch is the 532nd and 533rd, respectively, production engines from the RL-10 family. Built by Aerojet Rocketdyne, these RL-10 engines run on high-energy liquid hydrogen, and the RL-10 is equipped with precision control and the ability to restart, ensuring precise payload placement into the orbit. Now next we have the interstage adapter. Is same as SpaceX's interstage. They are composite structure that connect the main stage or the first stage, you can say, of a rocket with its upper stage, or the second stage, you can say. Now next up we have Vulcan's common core booster, or also you can refer it as the booster. So it measures 17.7 feet, that is 5.4 meter in diameter, similar to that of the payload fairing half, and measures 109.2 feet, that is 33.3 meters in length. Its tanks are made of orthograde aluminum barrels with spun formed aluminum domes and feature a common bulkhead. Fueled by liquefied natural gas, also known as LNG in short, and methane, the booster is powered by two BE4 engines. These BE4 engines are also the same which Blue Origin uses in its New Glenn launch vehicle, as they are produced itself by Blue Origin for um, United Launch Alliance as well. Now moving on, we have the solid rocket boosters for the Vulcan rocket. The Vulcan rocket can integrate up to 6 Northrop Grumman graphite epoxy motor GEM 63XL solid rocket boosters. For today's mission, it's 4 solid rocket boosters being used. These boosters are made from graphite epoxy composite, and that itself stands for GEM, GEM in short, with a throttable profile built into the propellant ring. Each of these boosters provide an extra 459.5 pounds of, 459,000 pounds of thrust, or you can say 2044 kilonewtons of thrust at liftoff. And this additional power augment the uh, common core boosters thrust during the liftoff. The Centaur avionics system handles guidance, flight control, and vehicle sequencing during both the booster and Centaur stages of the flight. Now we have the Vulcan main engine. It's just the same of those two pair of BE4 engine back in the common core booster, which is at the very bottom of the rocket. These are manufactured by Blue Origin, which I just mentioned. This engine will provide the booster propulsion, each generating around 2,400 kilonewtons of thrust at sea level. And this BE4 engine is a staged combustion engine with a single oxygen-rich pre-burner and a single turbine driving both the fuel and oxygen pumps. This engine will subsequently reduce the dependency on modern Russian kerosene-fueled RD-180 engines. So that's all about the rocket and its various parts. If you are feeling we are adding value to your viewing experience, please consider giving this stream a like, which really helps YouTube's algorithm to bring in more rocket lovers like you and other peoples to find out this stream. Also consider subscribing to us as we strive hard to bring streams filled with stats and details. Your kind support will really inspire us to work more hard to fulfill your expectations, and we would be super grateful for your encouragement. The versatile Vulcan rocket combines the best of today's Atlas V and Delta IV Heavy into a single core rocket to support this upcoming US national security launch, as well as in future it will be supporting commercial and civil launch in due course. Now, before proceeding, please give us a couple of seconds and to check if the liftoff time is still the same or not, and to keep ourselves updated. As of now, it's the same, so no worries. Also, well, there is no new update as of now. Well, ULA just provided an update that the weather is looking good, though a final assessment is still coming up uh, from their launch weather officer. So I'm keeping a track on that, and I will be letting you to know as soon as I will be receiving that update from them. Now let's go through the Vulcan's flight profile for today's launch. After the final confirmation of rocket readiness from the mission control team, the two BE4 engines back down at the common core booster with four solid rocket boosters will ignite, producing 3 million pounds of thrust to lift off Vulcan rocket away from PAT Space Launch Complex 41 at Cape Canaveral. Shortly after liftoff, the rocket begins a pitch over to attain the proper flight path while minimizing the dynamic stress it experiences during flight, also known as max Q. Vulcan then reaches the Mach 1, that is the speed of sound, and we can have a combination of 2, 4, or 6 solid rocket boosters as mentioned before, and for that Vulcan can be precisely configured to launch any payload from low Earth orbit to Pluto and even beyond that, adding approximately 460,000 pounds of thrust with each solid rocket boosters. This booster augment the rocket's total thrust during liftoff. Approximately 90 seconds into the flight, with their propellant expired, the solid rocket boosters will be jettisoned. The solid rocket booster jettisoned time occurred typically between 100 to 150 seconds after liftoff, and it all depends on the mission profile. Now, to steer towards the precise target in space. Vulcan's guidance system then takes the command. The Vulcan rocket then enters space, crossing the Kármán line. After burning most of its fuel to fight against the Earth's gravity, the 2BE4 engine shut down and the booster stage separates. The rocket then begins the second stage flight, which weighs less than 10% what it did at liftoff. The dual RL-10C engines on United Launch Alliance's center upper stage then ignite, providing a protective environment during the ascent of the rocket. Today's national security payloads are encapsulated inside a 5.4 meter diameter payload fairing. Just after two RL-10C Centaur engine ignite, the payload fairing will be jettisoned with the payload on board. The Centaur V second stage will head to its final geosynchronous orbit destination. Just a reminder, once again, I'll be providing you real-time live mission updates during the stream, so be sure to listen in. Now let's go ahead and briefly step through the trajectory for today's USSF-106 mission. Vulcan rocket leaving the pad from Space Launch Complex 41 from Cape Canaveral Space Force Station with the national security payloads on board for a somewhat southeast trajectory, leaving Florida's Space Coast heading into a geosynchronous orbit indicated by that green line on your screen. The red line close to the launch site you see indicates where the Vulcan's 4 solid rocket boosters will jettison and splash down, followed by that long red line where the first stage, that is the common core booster, will splash down after stage separation just a little later, leaving the east coast. Now, once again, just to remind you, we are currently standing by for a Vulcan rocket liftoff at 8:56 p.m. Eastern Daytime, 0056 hours UTC from Florida, heading on a somewhat southeast trajectory to a geosynchronous orbit for the USSF-106 mission for US Space Force's Space System Command, carrying 2 US national security satellite missions. Now let's take a look at the payload details for today's mission. Although one of the payload details we couldn't figure out, as it's typically a national security mission and those details are not publicly disclosed, but what we found the best and accurate we are sharing with you. On board today's Vulcan Centaur for USSF 106 mission, we got the Navigation Technology Satellite 3 or the NTS-3 under the Vanguard program, which is a pretty remarkable piece of hardware. It is developed by US Air Force Research Laboratory in partnership with L3 Harris Technologies, and will be heading for a geosynchronous orbit for operating there approximately 1 year or so to test some next generation navigation, timing and positioning technologies. L3 Harris Corporation integrated NTS-3 using Northrop Grumman's ESPA Starbus, building on Eagle's flight heritage. Now, what makes this NTS-3 so special is its ability to broadcast reprogrammable digital signals, somewhat that could make our GPS system far more resilient to jamming and spoofing threats. It's also going to be going to have the trial adaptive antennas to work on, agile waveform transmission, and stronger signal security, which could be a game changer for both military and civilian applications. Now, this is more than just a routine payload. This is actually the first Department of Defense experimental navigation satellite in almost 50 years, following the NTS-1 and NTS-2 missions from back in 1970s. The data and results from NTS-3 could help shape the next wave of upgrades to the GPS constellation and influence the future PNT, which stands for Positioning, Navigation, and Timing Systems. Well, there is also another spacecraft in today's payload, but that details are not being publicly disclosed since it's a national security mission. So all we had this details about the NTS satellite to share with you. Now moving on with some of the stats. We are approximately 10 minutes from the webcast to begin, so let's just quickly get done with some of the stats we have to share. The upcoming United Launch Alliance's Vulcan launch for USSF-106 mission is shaping up to be a huge event for United Launch Alliance, with several exciting milestones on the horizon. So let's take a look at them. It will be United Launch Alliance's 162nd overall launch and their third of 2025. This will also mark the third Vulcan launch to date and the first of 2025. Additionally, it will be the first Vulcan launch after getting certified and the first dedicated national security launch mission, which is also known as NSSL in short, on a Vulcan rocket. This launch is set to take off from Space Launch Complex 41, which will make it United Launch Alliance's 88th orbital launch from that pad and the 116th orbital launch from Space Launch Complex 41 overall. It's going to be incredible to see these numbers come together, highlighting how active and dependable United Launch Alliance has been with its Atlas V rocket and now Vulcan launches heading our way. Now let's move on and take a look at the bar graph showing the number of United Launch Alliance launches each year. Prior to today's launch, ULA completed its second launch of this year with Kuiper 2 mission, also known as KA2 mission, with the launch of Atlas V rocket back on June 23, 2025 from pad Sleep 41. That launch also marked Atlas V's 103rd overall launch to date and the second for this year. Now, with today's launch of the USSF-106 mission, United Launch Alliance's Vulcan rocket will mark its first launch of 2025 this year and the third overall launch. With United Launch Alliance's Vulcan rocket now certified for national security space missions, and United Launch Alliance recently winning a Space Force contract for continued critical launches, we were previously anticipating to see an increase in launch activity this year from them, but recently United Launch Alliance mentioned they are planning to target up to 9 launches this year and a sharp increase with planned 20 launches next year. Now moving on to this year's orbital launches, we have this pie chart on our screen. With this 176 orbital launch of this year, United Launch Alliance's says third of 2025, United States is leading with 114 launches with 64.8%, followed by China with 43 launches having 24.4% share of the pie, Russia with 9 launches with 5.1%, and 2 launches by Japan and 3 by India. Meanwhile, Europe with, I guess, let me check what is the status of Ariane 6 launch. Well, there is no update as of now. But if we will be not including the Ariane 6 launch, it's they are having 4 launches, and Australia with 1 launch, which marked the first Australian-made Eris rocket on its test flight to launch from its own country's soil, which was a really major milestone achieved for Australian space program. Although the flight lasted for 14 seconds around or so, but pretty sure with the data they got on their second attempt, they will be doing more good. Let me just check. Meanwhile, what is the condition of the? I guess they adjusted the liftoff time for Ariane 6 rocket for Meteop SE A1, which is a meteorological satellite for Europe. It's currently showing it's still they are having 7 minutes 47 seconds left for to have the liftoff. So as of now, Europe is still having 4 launches. Now moving on to this year's orbital launches by rocket variations, we have this pie chart on our screen. Vulcan rocket gearing up for its third launch for today. And previously we were expecting to have a Falcon 9 launch just maybe within some couple of minutes, but I guess SpaceX once again pushed it back by 1 day, now targeting tomorrow. With that, Falcon 9 was expected to have its 98th launch, marking SpaceX's 526th mission launch, with Starlink 17-4 mission from Vandenberg. Well, we will be streaming that event as well. The stream is posted on our channel, so don't forget to join us as we will provide you complete in-depth insights and stats for that launch as well. Now here on the pie chart, there is a section termed as Others, you can see, and which marks a significant percentage of share of the pie. And this includes all the less flown rockets in a year, which comprises of, as of now, including this launch, it will be 30 different rockets. For an example, it includes Japan's H322S, the final launch of H2A, European Space Agency's Ariane 6, Russia's Angara 1.2, or the A5 variant, China's some of the Long March variants, ISAR Aerospace Spectrum, Firefly's Alpha rocket, and other rockets. As they are flown less in a year, so we clubbed them together and kept them as others. We are trying to provide you a full breakdown on of this pie chart so that you can have a better understanding and a calculation of how many launches being made by each rocket variant. uh, Hopefully we will be able to provide you in our upcoming streams. So currently that's all we have the stats to share with you guys. We are now 2 minutes and a half from the stream to start beginning from ULA's end, and as of now the ULA's Vulcan launch countdown is holding back from T-minus 7 minutes. Like they will be having T-minus up to 7 minutes they will be holding. This is a planned built-in hold designed to give a bit of margin to ensure that they are ready for terminal count and today's launch window. Although there is just 3 minutes left in today's launch window that will be expiring at 8:59 p.m. Eastern Daytime, but currently we are targeting, and the liftoff is on schedule at 8:56 p.m. Eastern Daytime, 0056 hours UTC from Space Launch Complex 41 at Cape Canaveral. And during this planned hold, the final readiness polls of the launch team and management members will be performed. Hopefully we will be hearing those call outs during the comms, during the stream in their comms. It's time for the webcast to begin, so let's just move on. Although ULA didn't started the webcast as of now, and there is no more updates to share with you guys. Currently we are 20 minutes and a half minutes away from the Vulcan rocket on its third flight, carrying the first national security space launch on a mission dubbed USSF-106. Let's move on to the webcast page. Let me just set up the stream for you guys. Although there is nothing to worry, you are not missing anything. ULA is yet to start their stream. As soon as the webcast will be beginning, I will be making the feed available to you. Once again, just a kind request, adding value to your viewing experience is our top priority. If you somewhat felt that we achieved that, please consider liking this stream so that it can reach to more people.
I'm joining you from ULA's Advanced Spaceflight Operations Center here at Cape Canaveral Space Force Station in Florida. We also have team members on console at ULA headquarters in Denver, Colorado. Liftoff is scheduled for 8:56 p.m. Eastern Time. Launch windows vary by mission and are determined by the payload's destination. The USSF-106 mission will be deployed directly into a geosynchronous Earth orbit, or GEO, using ULA's high-performance Centaur V upper stage. Today's coverage will continue through separation of the rocket's payload fairing. For additional real-time mission coverage, follow along with our live blog at ulalaunch.com. And if you enjoy watching our live broadcasts, don't forget to subscribe to our YouTube channel for access to the future missions, launch, highlights, behind-the-scenes rocket content, and more. At this time, the team is not working any issues, and we're proceeding towards an 8:56 p.m. liftoff. Today's mission, USSF-106, is a multi-manifested flight that will be delivered directly to geosynchronous orbit. Navigation Technology Satellite 3, or NTS-3, designed, developed, and integrated by L3Harris with AFRL, is an on-orbit experiment to help modernize America's positioning, navigation, and timing capabilities by augmenting GPS to make it operate at faster speeds and lower cost. Let's learn more.
Well, now they will be playing some of the slides for the NTS-3 satellite. Although I explained everything about the NTS payload in today's USSF-106 mission, but just to update you guys, as of now, team is tracking no issues with the weather. Weather is in favor and no technical issues are also being addressed. As of now, all system continues to look good and ULA is on track for the liftoff at 8:56 p.m. Eastern Day Time. And you recently heard during the webcast that the payloads will be delivered directly to the geosynchronous orbit. It by that it means it will be not deployed in any of the other orbit which requires the need for on-orbit raising maneuvers using the onboard thrusters of the payload or the satellites. And the primary payload is the Navigation Technology Satellite 3, NTS-3, a flagship Air Force Vanguard program developed by Air Force Research Laboratories in partnership with L3Harris Technologies. Weighing around 1,250 kilogram, NTS will conduct a year-long experiment demonstrating reprogrammable digital signal generation, electronically steerable phased array antennas, advanced atomic clocks, and authentication protocols, all designed to resist GPS signal jamming and spoofing. Well, let me just quickly turn off the subtitle. We don't need it. Okay, they are playing some of the video which I showed you previously. It's from the manufacturing facility to the pad with the stacking of the Atlas, the Vulcan rocket. Now, meanwhile, you enjoyed this time-lapse view. Let me just tell you more about today's NTS-3 payload. This groundbreaking satellite is the first Department of Defense navigation technology demonstrator in nearly 50 years, reviving the legacy of NTS-1 and NTS-2 from back in 1970s, which were its key predecessors to today's GPS system. NTS-3 will operate in geostationary orbit to test next-generation positioning, navigation, and timing, which also stands PNT in short. So those PNT capabilities for both military and civilian application, potentially influencing the design of future GPS Block 2 and 3 satellites. Alongside the NTS-3 satellite, the mission also carries a classified US Space Force payload, details of which remains undisclosed but likely tied to national security communications or situational awareness. The success of USSF-106 mission will fortify Vulcan's place in national security NSSL Phase 2 contract, enabling ULA to support the Department of Defense with higher launch cadence in upcoming year.
CEO, Tori Bruno. Welcome, Tori.
Thanks, Chris.
Good to see you.
It's good to see you too.
We're a few minutes from liftoff. How you feeling?
Well, I'm feeling great. I mean, this is such an important moment for us to see Vulcan enter service, especially in the national security mission. The rocket's looking beautiful. The weather is clean. We're pretty excited.
Great. Liftoff's always an exciting thing to see, but equally exciting for me is the flight of the second stage. Centaur is just an amazing vehicle.
Absolutely, especially Centaur 5, and it really makes this mission that much more significant for us because this is literally the mission that drove the design of Vulcan. It's that direct inject to GSO exotic orbit with a really complex payload and an extraordinarily long mission timeline. It's literally the anchor that designed this entire rocket architecture. So as we enter into service, that's really something special. I might have preferred to have done a nice easy mission, but hey, this is what we built this rocket for, and it's about to go do it.
Great. Well, thank you, Tori, for your time. We appreciate the interview.
You bet. Thank you. I'm going to get back on console.
Great.
I like Tori. He is really a nice man. At least he responds to the tweets. We are heading on his way.
Channel 1. All personnel and visitors remain in the present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. RLM verify red line monitor and vent table are in the correct configuration for terminal count.
So right now we will be having the readiness poll.
Logs 2.
Centaur LO2 at flight level.
Roger.
LC Fuel 2.
Go Fuel 2.
Centaur LH2 at flight level.
Roger.
L minus 11 minutes.
LC switch to ready position. All steps are complete prior to the status check.
We remain in the planned 7-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Scott Barney will pull the team for the final go for the countdown. The launch conductor coordinates the launch team during countdown, similar to a symphony conductor coordinating an orchestra. 30 engineers are pulled to confirm the rocket is ready to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, the payload, the U.S. Space Force Eastern Range. Let's listen.
So currently the polling is underway to proceed with terminal count.
L minus 10 minutes.
Status check to proceed with terminal count. Vulcan systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LNG,
Go.
LO2,
Go.
water,
Go.
Centaur systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Go.
LH2,
Go.
house gas,
Go.
electrical systems airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
GCQ,
Go.
op support, go, comm,
Go.
umbilicals,
Go.
environmental control systems,
Go.
red line monitor, go, quality,
Go.
op safety manager,
Go.
ULA safety officer,
Go.
vehicle system engineer,
Go.
anomaly chief,
Go.
range and weather,
Go.
launch director,
Clear to proceed.
mission director,
This is the mission director. You have permission to launch.
proceeding with the count. ALC, verify T0 is set for 0056 Zulu.
Verified.
ABE, issue
Polling is
MR.
complete and the team is go for launch. From now until liftoff, you'll hear launch conductor Scott Barney and the team performing the final steps in the countdown procedure.
So we heard the launch readiness poll. Launch conductor Scott Barney verified that all systems are go to resume the on-time liftoff at 8:56 p.m. Eastern Daytime, that is 0056 hours UTC, which is, once again, just to remind you, it's just 3 minutes left in today's launch window that will expire at 23 8:59 p.m. Eastern Daytime, 0059 UTC. Now at launch minus 8 minutes, standing by to pick up the countdown clocks once again. The payload teams just verified their readiness to press on with the countdown. The spacecraft team will transition to internal power and enter launch configuration during the terminal count, which we are in. Now, meanwhile, would like to welcome Fiddler's Green for tuning in. Of course, kids love the launch, and we, being the old kids, we also love the launch. So hopefully we will have the launch. Let's be hopeful. Let's see the launch. And Vulcan is a much anticipated launch, at least for me personally. So let's see what happens. We are currently T minus 7 minutes approximately from the liftoff.
1, mark.
The countdown clock has resumed, and we are go for launch at 8:56 p.m. Eastern Time. After decades of launching our country's most vital assets into space on Atlas and Delta rockets, ULA is proud to continue supporting our nation, launching new capabilities atop our new Vulcan rocket. Let's take a look at our legacy of national security launches.
Well, I have to keep the audio off during this playbacks of the video on the feed because they contains copyrighted tracks and which we are not eligible to play them on our stream. So you can enjoy the views. Meanwhile, I will be updating you with the live updates. Currently we are at T-minus 6 minutes and 30 seconds approximately. The red line monitor is observing more than 1,000 parameters to ensure there are no violations to predetermined operating range through liftoff. T-minus 5 minutes and 50 seconds and counting. The Centaur 5 upper stage is undergoing final configuration for launch as the liquid hydrogen and liquid oxygen replenishment from the ground systems to rocket are being secured. So that's the update we got as of now. And the planned hold was also released previously. We just saw before this video they are playing. As of now, no issues from weather. T-minus 4 minutes 55 seconds and counting. Topping of the liquid nitrogen, liquid natural gas, fuel supply and liquid oxygen to the Vulcan first stage is being terminated in anticipation of the launch coming up.
East-southeast, and the temperature is 84 degrees Fahrenheit. The primary concern for launch today is the cumulus cloud rule. The range is green and for weather, and we are go for launch. Following liftoff, ULA's Vulcan rocket will be flying an easterly heading from Space Launch Complex 41. Here's a look at today's flight.
Well, I just described this video previously in the pre-launch discussion. Well, it's a easternly, mostly easternly you can say, but a little bit of having a south touch to the trajectory. But if you will be zooming out the trajectory, it's basically southeast trajectory, you can say. Meanwhile, we are receiving some of the updates I'm sharing with you. T-minus 4 minutes. Pre-launch pressurization has started for the Centaur 5 upper stage. The liquid hydrogen and oxygen cryogenic propellants here will be used by the dual RL-10 engines in burns to achieve a geosynchronous orbit tonight. T minus 3 minutes and 30 seconds. The Vulcan first stage is pressurizing to flight level after closing the liquid natural gas and liquid oxygen vent valves. The stage will fire its 2BE4 engine for 5 minutes to propel the vehicle out of Earth's atmosphere. T minus 3 minutes and counting, the acoustic sound water system at Space Launch Complex 41 is almost ready. The system will flow water at the rate of 7,300 gallons per second to dampen the sound intensity of the launch. Oh, we are getting so close to the liftoff. Let them be done with this video. I'm just patching in the mission audio feed. As of now, they are having copyrighted tracks, so we are sorry for that. Although I described everything possible.
Once we lift off, viewers watching the launch from Florida and points east may be able to see Vulcan in flight. To get a closer look at this visibility map, check out @ULA Launch on social media.
Currently T minus 2 minutes and counting, the Vulcan first stage and Centaur 5 upper stage are switching from ground power to internal batteries for launch. In next few seconds, the start command will be issued to the launch sequencer, and the sequencer will perform independent verification of systems for the rest of the countdown, control the detachment of umbilicals from the vehicle, and release the rocket from the pad at liftoff. So let's listen into those callouts.
140.
Launch enable.
135.
FTS armed.
T minus 90 seconds. The launch vehicle, ground systems, payload, and eastern range are go for launch. For those of you just tuning in, I'm Chris Veltri, joining you for today's live coverage of USSF-106 atop ULA's Vulcan rocket. At this time, the team is not working any issues, and we're proceeding towards liftoff at 8:56 p.m. Eastern Time. T minus 1 minute.
Rock, report range status.
Range green.
.45.
Vulcan tanks at step 3.
34. 30. EE4 start box, go. 28.
Verify ECS ruse for launch.
Verified. 20.
Status check.
Go Vulcan. Go Centaur.
Go SF-106.
15. 10.
T minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch Alliance Vulcan rocket carrying USSF-106 for the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Thrust. Half mile in altitude.
So we have a successful liftoff with a huge roar. United Launch Alliance Vulcan rocket
Fuse down to closed loop control.
is on its way with the US national security space launch.
And we've completed our roll program. 3 miles in altitude, half mile downrange. And Mach 1, Vulcan is supersonic. Vehicle's traveling at 1,500 miles per hour, right down the center of the range track. Max Q, maximum dynamic pressure. Engine parameters continue to look good. Hydraulics good. Five miles downrange.
You are hearing Daniel Brunson providing launch vehicle ascent data.
Good indication of SRB burnout, preparing for SRB jettison. B4s continue to burn nominally.
We'll be having the SRBs to jettison. There we go.
An indication of SRB separation. B4 is entering its first throttle bucket. And guidance enabled. We've been able to close loop steering. At this point in
We
flight,
just heard
Vulcan is now half
confirmation of solid rocket booster jettison. These foreboders augmented the thrust of the main vehicle engines at liftoff, giving the Vulcan rocket an extra boost on its journey to geosynchronous orbit.
27 miles downrange, continues right down the center of the range track, traveling at 3,200 miles per hour.
The Vulcan main engine continues to operate as the B4 burn a mix of methane and liquid oxygen. The rocket now weighs half of what it did at liftoff, having consumed nearly 1 million pounds of propellant already. Awesome views out there. Shines like a star there.
Pyro valves on the upper stage. .34 miles in altitude, approaching 4,000 miles per hour. Body rates continue to look as expected.
The Vulcan rocket remains on course, flying down the center of the range track to space. The main engine are firing as programmed, generating more than 1 million pounds, that is 4.4 meganewtons of thrust.
Right down the center of the range track.
Well, Fiddles Green, glad to hear from you that you got to see the launch in real, and absolutely happy for the kids as well. Hopefully I can see a launch in real someday. As of now, everything is looking good. Sooner we will be having these 2 BE4 engine at the common core booster to shut down and to have the stage separation, where the common core booster will be separating from the Centaur 5 upper stage. This common core booster will be approximately flying for 5 minutes or so before getting jettisoned.
Good activation of the upper stage PU motors. Vehicle's traveling 8,400 miles per hour.
The main engines will soon step through throttling segment to maintain constant G acceleration limits in preparation for our conclusion of the first stage flight. The Centaur 5 is also about to begin its cool down sequence during the boost phase of flight in preparation for the RL-10 engine's ignition following the stage separation.
Prop on, Elsie.
And good indication of shutdown. An indication of Centaur separation. We got pre-start on H2 and O2.
We are getting some onboard views of the Centaur 5 upper stage. We just saw two of those RL-10 engines, RL-10C engines.
Set to open loop control.
We have a successful staging. Ignition of the Centaur 5 upper stage and payload fairing jettison is confirmed. The vehicle now weighs less than 10% of its liftoff mass. The first stage of flight was completed with booster engine cutoff, also known as BECO here instead of MECO, what we generally see in SpaceX's launch, followed by separation of the Vulcan rocket's core stage. That enabled the Centaur's 5's RL-10C engines to begin the first of their planned firings today to achieve a geosynchronous Earth orbit. The 5.4 meter diameter clamshells payload fairing enclosing the multi-manifest payload during ascent through Earth's atmosphere has separated as planned. Now currently they are playing some of the videos for, I think it's for national uh, USSF, I think. Everything went as planned. The liftoff went successfully, although I was a little bit skeptical because previously on the second flight, we did saw on the second flight of Vulcan, we did saw the uh, anomaly of one of its solid rocket booster that caused a reduced and asymmetric thrust during ascent. However, the performance shortfall was fully compensated by Vulcan's other stages, and for that reason, subsequently on March 26 back on 2025, ULA announced officially that Vulcan rocket has been certified by United States Space Force to fly National Security Space Launches mission. After a thorough follow-up investigation for that SRB anomaly struck during its second certification flight. Uh, I forgot to say this detail that today's Vulcan rocket is designated with the serial number V003. That's the third flight for Vulcan. For that, the serial for it. It left the pad with around 3 million pounds, that is 13 meganewtons of thrust from the main engine, with 4 SRBs to launch the USSF-106. Well, previously on the Kuiper launches, we did saw the Atlas V rocket with 5 SRBs to launch the heaviest payload yet flown on Atlas V rocket, that is the Kuiper satellites, a batch of 27 of them satellites, Kuiper satellites. But that particular Atlas V setup with 551 configuration left the pad with 2.7 million pounds, that is 12 meganewtons of thrust. So although there was more SRBs but less thrust compared to what Vulcan produced with 4 of them. Although the difference is 0.3 million pounds, but that matters a lot.
Into today's flight. What a beautiful evening we had in Florida for launch today. We got to hear from ULA's president and CEO, Tori Bruno, about how Centaur is truly one of a kind, and we witnessed boost phase for Vulcan's inaugural national security mission. For more information about ULA, the Vulcan rocket, and USSF-106 updates, please visit ulalaunch.com and subscribe to ULA's YouTube channel. And plan to join us for our next launch, an Atlas V rocket launching Kuiper 3 for Amazon. As we sign off this evening,
so that's up. We won't be getting any views, so now we will be having the recap.
8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch Alliance Vulcan rocket carrying USSF-106 for the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Thrust. Half mile in altitude. Completed our pitch and yaw program. Body rates turn.
The launch went flawless, absolutely perfect. So we just heard the update from ULA's event host. The next up will be the Kuiper satellite launch from ULA. As today it was a national security mission, so we won't be getting any payload views or the second stage views, but fortunately in between the webcast we got a couple of seconds of view from the Centaur V upper stage. So with that, we will also wrap up our coverage for now. But before that, want to thank you for joining us, watching our live launch coverage. We really can't do this broadcast without you and your encouragement. So thank you so much for your continued support for everything what we do at AstroYonder. Please be sure to check out our upcoming launch coverages on our channel. Also, check out our social media handle on X for the latest happenings in the space industry and updates on upcoming launches. Guess the link got posted on the chat section. Once again, thanks for watching the stream with us and being a part of our journey here at AstroYonder. Hope you enjoyed the stream. Wishing you a nice week ahead. This is Dipto from AstroYonder Live. Sign off for now, and we will see you on the next stream.